Okay, it's well. I'd like to draw a conclusion what I've been doing on these videos to draw how to get more energy into your electricity to lower electric bills. So I explained in the prior videos that the atomic spinning atom spins around. What's been kept a big secret for hundreds of years. The center is a next smaller atomic spinning atom. It's got electricity too, what you'd call this is the surface of your reality atom of your world, and inside the surface is called the subatomical environment. So this would be called a subatomical atom with its own form of subatomical electricity. And when it comes out, the electricity, you call it light. But anyway, that gets technical. Anyway, it spins around. So the slower moving light is the bigger spin. As you get towards the center, the electricity, which is a speed called voltage, the voltage is the speed of electricity. It spins faster, so that's known as higher frequency also. So the two go in hand in hand. You want to gather more energy, it's higher voltage, higher frequency. So as it spins, and it fundamentally, this energy comes in from space where there are no stars through our atmosphere, and it flows through the different layers of the atomic atoms of the atmosphere. So it releases it, and it would release it in wave like motions. This represents the slower moving light, like red light, infrared light. Faster moving light, blue light, and higher would be this level of light. So when you get to high, that's part of the faster moving electricity, releasing light, which is faster moving light, known as higher voltage. So if you can gather that at high voltage with high frequency, you can put more energy into your electricity and then take it to lower voltage, and you increase the amount of volume of current, lower voltage, and it becomes more useful electricity at a cheaper cost. So it goes to the lady of a man that wanted to maximize his understanding of this, called a man you can look up the internet called Nikolai Tesla, high voltage man. And he went moved, set up shop in Rhode Island and built a structure like this to gather the energy. These are the legs of a structure. This is a half ball of metal, and he had these type of things as energy collecting, called dish antennas, to collect the high energy, because he wanted to get up to that like microwave oven or higher, above radar. So of the energy flowing from space, that would go into the metal energy collecting disc, and they were all be connected to a steel pipe down to his laboratory where he'd have his transformers to lower voltage. So this was what he set up at 200 feet tall in Rhode Island, New York area. But he had a problem because he was at the bottom, near the sea level, and he was at the bottom of the atmosphere. So all that energy of high energy of light he wanted to collect into his electricity was interfered with what's called a high density of air. And another interference would be called the moisture of the ocean, which he was close in Rhode Island near ocean water. So he packed his bag and set up a new shop, and that was a 200-foot tall tower. And he moved to a place called Colorado Springs, Colorado. That's higher in elevation, less density of air, less air, and less moisture dominantly. So he bought, I guess, a barn type structure to set up his transformers and laboratory equipment. And the tower on Rhode Island was 200-foot tall, 10 energy collecting tower. He put a single wire um, above the ground to collect energy from the surrounding environment coming from space into his steel pipe. So he didn't have to have that one structure of called parabolic antennas, gather collecting antennas. So I guess it was efficient enough. So he attained the 10 million volt level, which was a tremendous amount of energy. And so he wanted to get up to 100 million volts. And from the scientific writings, based on high enough frequency, if you could do that, and you're building called an energy collecting antennas, he was calculating he could get up to maybe into his absorb the light energy from space to generate an energy storage of electricity about 1 billion watts of power. Be careful. Don't try doing this because that's a dangerous level of energy. So another reason of getting out of Rhode Island being near the ocean is because it had high how do you know you're at 1 million volts, 5 million volts, 10 million, 50 million volts? Well, you separate metal balls, and this is called a spark gap metering, like a high voltage meter, and you separate them a certain distance. And based on mathematics, if you draw electrical arc, you know, based on the distance, that you are at 1 million volts. You separate them even further, you draw electrical arc, you then determine mathematically you're at 10 million volts. But the factor called variance was the fact that he was at the bottom of the atmosphere with a lot of spinning atoms in the atmosphere, interfering with drawing the electrical arc. This is like a voltmeter type of environment called spark gap metering. You can look it up. And moisture from the ocean. It all interfered with reliability when you could draw electrical arc and know what voltage you're at. So at Colorado Springs, Colorado, higher elevation, less moisture, dominantly, the distance of your separator of metal balls would determine what voltage you were at. So I guess he was shooting electrical arcs over 1 miles of separation of his metal ball structures. That's a long distance for draw electrical arc up in Colorado Springs, Colorado. So I think that was one of his motivation to move to Colorado Springs, Colorado, a man of high voltage generation and energy collection called Nikolai Tesla. So I thought I would cover some of the physics of if you look it up, Nikolai Tesla, and see this tower ball structure, what he was doing, he was collecting energy that flows from space to the atmosphere into these metal collecting disc antenna type systems to collect it into his electricity of transformer. So that solves the mystery of what Nikolai Tesla was doing in the past. So I hope this has been enjoyable. So thank you very much.